Trevor.
Yesterday I recorded like 10 minutes of notes, forgetting that I unplugged my microphone. So then I had to plug it back in, and I wrote a note on all the things I posted. I promise the volume comes back after 10 minutes. Oh, we're going to start over. Who really watches them anyway? Probably no one. Alright, so if I add these, f plus g of x, what do you think you do to add functions? You just add them, right? If they have anything in like terms, you add them together. If they don't, then you just put it all together as one thing, like adding separate things. But in this one, I'll show my work. X squared plus 2 plus 2x squared minus 1. I could say that's 3x squared plus 1. Right? 1 plus 2, 2 minus 1. So you really just do what it says. Add, subtract, multiply, divide. I'm not really going to spend that much time on here unless you have questions. Elizabeth, Jimmy dropped the class, so if you don't want to have to be in a row by yourself, you can move his seat. Just saying. I mean, if you don't have to be like the odd one out, right? This is it. We're down to 15. Really 14, because James just here for fun. Yeah, this was my biggest class. Like, we were at 20-something, 26.
Yeah, when I first got here, you were mad at me for ending the class.
There's too many. What really stings is we ordered like 8 new books because we were short on books, and if I just would have waited a couple weeks, we wouldn't have needed them. It's a lot of money. Like, each book costs like over $100, and so it just kind of stinks that we ordered almost $1,000 in books when people just dropped out. So, but you know, who knew? I know. This class is getting smaller. Calculus has grown. So, who would have thought? Subtraction. People forget that to subtract everything. So remember that if you're subtracting g of x, you're subtracting everything. So that would become minus 2x squared, and minus negative 1 would become plus 1. So just remember to distribute your negative, and then that would just be negative x squared plus 3. If I multiply f times g of x, you really just multiply them, and I know you want to be lazy and you want to just say, let's leave it like that, right? But you could FOIL that out. The great thing is when they have nothing in common, if this was a square root and this wasn't, then you can't multiply them. So you just leave them like that. But this one we can multiply out and say 2x to the 4th, I'm going to do that in my head, negative x squared plus 4x squared would be plus 3x squared minus 2. And then the last one, if I divide f divided by g, I really am just dividing them, and I say x squared plus 2 over 2x squared minus 1. And you can't simplify that. Very, very rarely can you simplify that. But the domain part, all right? So what is the domain of x squared plus 2? Yeah, it's a parabola, right? Quadratics, polynomials have domains of all real numbers. So if this is all real numbers and this is all real numbers, when I add them or subtract them or multiply them, is my domain going to change? No. If it's all real numbers to begin with, it's going to stay all real numbers. So the domain for this one and this one and this one, the domain is just still all real numbers. Nothing is restricted. But when you divide, you have to be really careful because now you're dividing by 2x squared minus 1. So usually your domain's going to change on that last one because you have to say, I can't have 0 in my denominator, so you have to say my domain, have to exclude whatever x can't be, or just set your denominator not equal to 0. It's not allowed to equal 0 and solve that. Sometimes you can do that in your head. Sometimes maybe you have to do a little work. Like, that would be 1/2. Take the square root. Well, that's gross. X equals plus or minus the square root of 1/2. not really very nice to leave a square root under a radical, a fraction under a radical, but whatever, we're just going to say that. We're going to say our domain is everything but plus or minus radical 1/2. You could write that in interval notation or set notation. Interval notation is not very fun to write, right? Interval notation would be negative infinity up to negative square root of 1/2, union negative square root of 1/2 to square root of 1/2, union square root of 1/2 to infinity. That looks gross, right? This is where people like set notation. What about this? X such that x cannot equal plus or minus the square root of 1/2. Does that seem like an easier choice? That's better, right? Your book does some crazy stuff about absolute value. Like it says, I don't know, I don't even want to talk about it, but they try to get around all that plus or minus by doing absolute value. I'm going to give you one question like this on your homework because it's really pretty straightforward. It's just don't forget the domains part. The majority of this is all about composition, which maybe you remember. Have we done that this year? I don't remember. Maybe not. Let's do remember that composition is a whole different operation. It's not multiplication. It's when you take one function and you put it inside another function. So given two functions f and g, the composite function, right, you use this little notation, which is like an open circle. It doesn't mean times. You actually read that as f of g of x. And I always say you can always replace that open circle with another set of parentheses. So f of g of x is like saying you're taking the g of x function and you're putting it in the f function. Kind of tricky about this is the domain. It says the domain of f of g is the set of all numbers x in the domain of g such that g of x is in the domain of f. Last year in the college algebra book that we taught out of, they made you find the domain without actually doing the composition, and it was kind of really confusing. The good thing about this book and this test from Ivy Tech is they don't ask you for the domain unless they ask you for f of x, f of g of x, which is a lot easier. So we'll talk about that. They do ask you to find the domain. Those of you that took pre-cal with me, we didn't really talk about the domain of f of g because I said it was kind of complicated and I didn't want to do it, but in this class they make you do it, so we can't skip the domain. So let's just practice with a nice one before we go to ugly stuff, right? So first of all, what if they gave you numbers? I think it's easier when they give you numbers instead of x's, because if you just remember to start with the inside function and work your way out, you don't even have to actually do the composition. So if this is f of x, and this is g of x, and they ask you to find this stuff, first of all, you could rewrite every composition as parentheses. And if you just kind of do order of operations, work with the inside function and then work your way out to the outside function. Did I miss something? If I do g of 1, you've been doing that since you learned function notation. So forget about f, leave it out there, and just do g of 1. And g of 1 would just be 4 times 1, which would just be 4. Then you do the outside function. So f of 4, you plug 4 in for f, and I can show my work here, I guess, a little bit better. That would be 2 times 16 minus 3. What is that, 29? So your answer is the number you get at the end. So you do the inside function and you work your way out to the outside function. Composition is not commutative, which means order matters. When you do g of f versus f of g, you don't usually get the same answer. They like to trick you up and ask you to do f of f or g of g, but you still just do the same thing. So I'll do one more, and then you're going to do the other thing. So if I did g of f of 1, now f is first, so I plug 1 in here for every x in f, and I would just get 2 minus 3, which is negative 1. Then I plug plug negative 1 in for g, and I would get negative 4. So if you haven't already done so, do C and D. Do f of negative 2 and g of g, f of f. It just means you're going to plug it into f and then plug it into f again. So get an answer and then plug it back into f again. You're learning so much math in here. You're just daydreaming out. Hello? He's absent. It's a failure in that absence. $47? Did you get 47 for C?
Yep.
And negative 16 for D? Did you get negative 16? Questions about the number part of that? All right, let's do the actual function part of it then, where we don't have. What did I do? What's wrong? 47? Because f of negative 2 would be 4 times 2 is 8 minus 3 is 5. Did you get 5? You have to plug it in here though, right? Did you plug it in there?
Yeah.
What did you get?
I don't do it all together.
Well, you can't. How do you do it? You can't do it all together, right? Like you have to do it. You have to plug in one number at a time.
I got negative 7. Where's that?
Yeah. So it's not negative 7. That's.
Negative 5.
You have to plug negative 2 in for x. So negative 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. Right. So like when I do this, I don't keep an x in the file. Like I do it with all numbers. We're gonna do x stuff down here and then see if maybe we can figure out what you're doing incorrectly. Because what you're doing is you're doing the x stuff and then plugging your number in at the end, which you can do, but I think it's way more complicated. That's what I think. What about this one? This is terrible. A, B, and C. That's a whole lot of stuff to do. We might not do all of these on the one in a minute, but we'll do it on the first one. For the given functions f and g, find f of g, g of f, and g of g, and state the domain of each composite function. Here's what's great about domain of composite functions. What's the domain of 2x plus 3? What's the domain of 3x squared? So when we do the compositions, the domains are still going to be all real numbers. Nothing's going to change there. If the original domains are not all real numbers, that's when you have to really think about what's the new domain, which basically just means you have to take into consideration the original domains as well. If I'm doing f of g and I just want the new composition function, I'm going to have x's left in my answer. So it really helps me if I write it out with the parentheses. And just like if I was going to plug a number in there, I'm going to plug an entire function in, which means I'm going to take g of x and I'm going to plug it into f. So if you want to show work there, leave the f alone, and then replace g of x with what it equals, which is 3x squared. So I'm going to take 3x squared, and I'm going to plug it in to f everywhere I see an x. So I'm going to get 2 times 3x squared plus 3. And then I just simplify. So I am not multiplying these functions together. I'm taking one function and putting it into the other function wherever there's an x. So I would get 6x squared plus not solving anything. It doesn't equal anything. I just get a new function. Why did I do it? Sorry. Because it's just, I don't know why I did that. I just put my parentheses in. So that should really be 6x squared plus 3. Glad someone knows what's going on. I just put my parentheses in the wrong spot. Thank you for telling me. That 2 does only go to this, because that's just 2 times x and then a plus 3 separate. Yes? What if you did g of f? What does that look like? Again, now f is the inside function. I'm putting it into g. So wherever there's an x in g, I'm going to replace it with that f function. So now that's going to be 3 times, instead of x, it's going to be 2x plus 3 squared. If you were going to work that out, you can't distribute the 3 first. You got to square it out first. So you get 3 times 4x squared plus 12x plus 9, which is 12x squared plus 36x plus 27. Again, we want to make sure we realize that f of g and g of f are 2 different functions. Order matters of which one goes first. Questions about that? Do you have memories of doing this? I feel like as opposed to what we do in Algebra 2 and even pre-calculus, they like to get crazier with these functions than we like to do in those classes. This one's nice because it's a nice polynomial functions. We can say the domain here for all of these is all real numbers. I didn't do g of g. What would g of g look like? That would be g of 3x squared. So I'm going to take 3x squared and plug it in for x. So I would get 3 times 3x squared squared. So again, order of operations, forget about that 3 for a minute. And square that would be 9x to the 4th. So I think you should just get 27x to the 4th as g of g. Okay, I think I have 2 more in here, but maybe we'll just do one more. So we want to do the fraction one, or we want to do the square root one? Well, on Monday we'll do the other one too. We'll go back because the notes on Monday are not that much more to do. But like I said, they like to get more complicated. It's going to be more complicated with the fraction because if you take a fraction and plug it into another fraction, you're going to get this ugly complex fraction that you're going to be required to get a common denominator on to simplify. That's what makes it ugly. With the square root ones, you're going to have to think about what you're going to have restricted domains. Same thing on this one. We're going to have some domain issues. So let's just do f of g on this because I don't want to spend forever on this. If we just do f of g of x, that means that I'm going to take g of x, which is 4 over x minus 1, and I'm going to plug that into here, right? So in f of x, everywhere there's an x, I'm going to replace it with this. So I'm going to get 1 over 4 over x minus 1 plus 2. See how that's not so much fun? So this goes all the way back to what we did at the very beginning of this year. We want to simplify this. So we need to get a common denominator down here. Which isn't so bad, right? That's just 2 over 1. So the common denominator means I'm just going to need an x minus 1 over here, right? X minus 1 over x minus 1. So that's going to be 4 plus, if I distribute that, would be 2x minus 2 all over x minus 1. You agree with that? And then if I have 1 over a fraction, fraction, if I multiply by the reciprocal, isn't that just going to flip it over? So that's going to change to, I'm going to write it over here. 1 times, flipping it over would be x minus 1 over 2x plus 2. Is that true? You can't really simplify any more of that. F of g of x would equal x minus 1 over 2x plus 2. So, what about the domain of this? What couldn't I have in this new problem? What value would have to be excluded? Like, what would make the bottom equal 0 down there? If you're not sure, just set the bottom can't equal 0. X can't equal negative 1. Yes? But we also have to take into consideration those original problems up there, yes? I didn't get rid of it. I added it to this, right? So when I had 4 plus 2x minus 2, I just combined like terms. 4 minus 2 is 2. So they just combine together. Other questions on where I got that? No, it's okay. I just, trying to think. There's one of these we do. I think you have to take into consideration the domain of, what does it say? We include one of these, but not both of these. Doesn't that seem weird? I know, it really freaks me out every time. That's why I have to think about it. The domain of f of g is the set of all numbers in the domain of g such that g of x is in the domain of f. In the domain of g. Okay, so what number would you have to exclude from g? 1. So that number carries down to this. So we have to say our domain is excluding 1 and negative 1. So you have to exclude the domain of what you plug into it plus the domain of what you get out of it. But you don't include the domain of the f function. I know it's really weird. We'll talk about it more, I think. So we could say x could not equal plus or minus 1. Or you could do the implementation. Do you want to just do the square root one too? That's the next one, right? Square root one.
Yeah, the last number C.
Oh yeah, let's not do that. That's ugly, right?
Yeah.
Did you get a square root of a square root? There's not really a great way to simplify that.
How would you though?
I think you just leave it as a square root of a square root, or you can change it to a fourth root, right? A square root of a square root would be a fourth root if it's all a square root. But it's kind of weird to say square root.
You told me I should go.
You would be careful.
I know. Like,
Just because you're good at math doesn't mean you should teach math.
it does not. If somebody's like, how do I do this? Tell me the
I
answer.
don't care anymore.
Yeah.
You just typed it.
Here's the answer. Like, say that.
This one's really not that bad to do this. I'm going to do this really quick, whether you want to do it or not. S of g of x would be f of the square root of x, which means where am I plugging the square root of x in? Take it and plug it in for f. So I would get the square root of x squared minus 16, right? What is the square root of x squared? I think, technically speaking, are you supposed to put like, I don't know. Isn't there some rule about absolute values on?
Yeah.
I always just disregard that. But.
The domain just all positive numbers because
Right. So this is where the domain stuff really matters. Like on the fractions, it's kind of obvious stuff has to be eliminated. But on this one, if you just looked at your answer, you would be like, oh, the domain's all real numbers. But you have to take into consideration that g of x domain. And g of x cannot be a negative number. So although our composition, theoretically you could plug anything in, you have to take into consideration the domain of the inside function. So our domain here is still only positive numbers, or including 0 to infinity, or set notation, that would be x is greater than or equal to 0. And so the big thing with composition is, one, you got to understand that you're plugging a function in. Two, the domain is the domain of what you get plus the domain of the inside function. So if it was g of f, right, if we change the order, then you have to take into consideration of what f's domain is. So it matters which one's the inside function. What are you looking at?
Block the answer.
0. 0. See, look, we had time. I was worried about the time. Your homework is really short. Look. It looks
so
like
yeah, it's not short. Okay, so it's not short. I mean, it's easy, but it's not short.
It's one of each number. I mean, like one of each kind. So number 1, they ask you to do the adding, subtracting, multiplying, and dividing of numbers. Number 4 is adding, subtracting, multiplying, dividing with not numbers, so you leave it in terms of x. Number 12 is f of g, g of f stuff. And then 21 and 22 are the do the f of g, g of f, find the domains. Monday I'm going to add one more thing to this, and we'll practice this a little bit more. And then on your quiz on Tuesday, there is a question over composition, so that's why we could take the quiz.